Good afternoon, everybody. Very warm welcome to this session on unleashing the potential of ports and maritime logistics via data-driven solutions, opportunities and challenges. A very long title, and I will disambiguate this title in a few moments. Let me quickly introduce myself. My name is Andreas Metzger. I have the pleasure to moderate this session here, which is part of the Data Spaces track. I'm leader of the clustering activities of the DataPorts data platform project of the Big Data Value PPP. And in the past, I was technical coordinator of the Big Data Value PPP Lighthouse project on big data for transport and logistics. And in addition, I'm also supporting the BDVA Association as Deputy Secretary General. Before I introduce to you our established panelists and speakers, brief housekeeping rules. I think many of you have seen this now multiple times in this conference. So you all will be muted, except us as speakers and moderators. If you have any questions and you would like to interact with us, please post them in the Q&A box in Hoover or in the chat box in Zoom. So whatever channel you like, it will really reach us. Or if you want to speak, you can also raise your hand and then we can give you the floor. In any case, if there's any problems or issues, you can also post in the chat, and Matja, who's our session host in technical support, will help you then deal with these issues. Okay, let me introduce our speakers. I'll put them here in the order of the presentations they will give. We'll start with Carlos y Palau from Universitat Politécnica de Valencia. He's the coordinator of the Pixel project. Yes?
Andres, sorry, just to interrupt you. Like, we are not seeing your screen.
Ah, sorry, that's my fault. I always do this in Zoom. Okay, now you should see.
That's perfect. Thanks. Sorry for the interruption.
Thank you very much. Okay, so I'll start again introducing our speakers. So the first is Carlos y Palau from Universitat Politécnica de Valencia. He's coordinator of the Pixel project. Then we have Vivin Kürsi from Intrasoft. He's one of the co-leaders of the BDVA subgroup on transport or mobility and logistics. We have Angel Martinez Cavero, who is the innovation manager in the ASSIST-IoT project, and he's from ProDevelop. We have Fotis Okonomi from Danaos Shipping. He's the coordinator of the SmartShip project. We have Santiago Cáceres, who is the coordinator of DataPorts, and he's from ITI in Valencia. And last but not least, we have Tuomo Tuika from VTT, and he's one of the leaders of the task force on data sharing spaces of the BDVA. So as you see, we have a quite diverse set of speakers here, and we'll also have the opportunity then really to look at this topic here on how we can really use data-driven solutions for port and maritime logistics from different angles. To better understand how we organize this session, or this hopefully a very interactive session here, this is a little kind of flow of what we're trying to do. So we start with giving you some insights in what are the opportunities if you use data-driven solutions, data-driven AI, data analytics in this sector. Reporting from two different projects and also from the subgroup on mobility and logistics. Then we get the perspective a little bit more from the technical realization side of what would be existing architectures and building blocks to make these data platforms, data spaces possible for maritime logistics and mobility. And we have three projects here presenting, ASSIST-IoT, SmartShip, and DataPorts. After each of these two main introductory parts, we will have a brief Q&A if there's needs for clarification, so if anything from the audience needs further clarification. Before we move then to a more, let's say, forward-looking presentation from Tuomo towards the European data sharing spaces. And this will then set the scene for entering the discussions into what would be interesting challenges for the future data spaces, data sharing spaces, for mobility and logistics in general, but more specifically also for maritime logistics and ports. Okay. So this was my very brief introduction, and I think we can then already start by giving the floor to Carlos, who will present the opportunities of data-driven services from the Pixel project. Carlos, the floor is yours. I stop sharing.
Okay, thank you, and thank you, Andreas. I start sharing my screen, and we can start. Okay, can you see the presentation mode?
Very good.
Okay, so first of all, thank you, Andreas, for giving me the floor. And I'm going to present Pixel, the project that I'm coordinating, that is going to finish in 4 months. And in this project, we aim to use the power of data and information coming from IoT platforms for environmental leveraging ports. So the context and origin of Pixel, why Pixel was born. Pixel has the aim of being able to measure different heterogeneous data imports, gathering data that is coming from different sources. And this feasibility of managing and analyzing all this data prevented port to optimize different operations. And this has an impact in the environment. So the thing that we found is the following. Typically, the larger ports, very big ports, there are not many number of these ports in Europe, are able they manage the majority of the gross weight of goods, but and additionally they have the majority of the funding in order to implement different measures. But when it goes to the long tail, we have a lot of data available, and it's very difficult, and it's far from optimal, the management of all this data in the different ports. So we try to focus in these small medium ports, and later on try to export the different architecture and the management of the different data to larger ports. So in the case of Pixel, we have port managers, we have the port market, we have data, we have IoT tech providers. Each of them have different requirements, different needs and different things, and it arises to the management and the need of working with Pixel. So some ideas that we have, or some potentialities out of the Pixel products in order to exploit data is, for example, the use of eyes in order to estimate the estimated time of arrival and different values that we are calculating with this data, with the port, what we call the port environmental index. But it's a way of measuring the impact that the port is having in the environment, in the city and the surrounding areas. And with this data, we are managing the information, and we are gathering all the information about these aspects. Additionally, using satellite imagery, we are able to optimize the information about the seaside inside the different ports and try to optimize the seaside terminal operation and planning. So this is one of the aspects of Pixel. We are gathering data from the gates. We are gathering data from the environmental sensor that we are deploying. We are gathering data from eyes. We are gathering data from different aspects that are coming and the typical operation from the ports. And with this, we are able to determine and to analyze different data and calculate the impact of the ports in the environment thanks to the management of this data. The management and the exploitation of this data will come and will develop in the improvement of the different operations. And in the case of Pixel, we try to drive the digitalization towards the port of the future. Pixel was one of the ports, one of the projects that was named in the cluster of the ports of the future. And we try, and what we have done is to provide interoperability to all the different data sources. This is really difficult in the environment of ports because we have different entities, different stakeholders managing different aspects in a port. We have from the stevedores, from the container terminals, the drivers, the port authority itself, and different entities that are managing different data. So we have to create a common interoperability. We have to manage and to deal with a centralized management of this data, although we have the possibility, and we are exploring the possibility in the business model to move also to an edge approach, not to centralize everything in a single point. And we consider Pixel as an integrator and a tool to managing all this data, although we focus in the goal of Pixel, that is the environmental information. So with Pixel, we try to democratize and provide awareness to the different entities in the port and provide a value and to provide an awareness of which is the situation of the environmental aspect of port. We can see on the right side of the slide, the different data sources that are coming to a single point that is Pixel. So the innovative proposal of Pixel, we try to reduce the environmental impact of the different port activities, reduce the operational infrastructural cost, improve the logistic efficiency in multimodal hubs like are the ports, and provide a better integration between the port and the city. Consider that we have a lot of port cities within Europe. For example, the 4 ports, although 3 main ports of the pilot that we have in Pixel are 4 cities like Bordeaux, Thessaloniki, and Piraeus. And we try to have less dependency on different technology providers when we try to digitalize, thanks to this homogenization and this aspect. So the backbone, the innovation backbone of Pixel is IoT and the data, and the key components over this backbone are the port environmental index. That is a value that we calculate in order to analyze and decide which is the port the impact of each of the ports. Can develop different port predictive algorithms and analytics, for example, based on these data. Provide or create a port ecosystem around the IoT platform, that is the Pixel platform, and try to provide different models and scenarios in order to optimize the different operation within the port. So this is the architecture of the Pixel port. Everything is based in what we call the Pixel Information Hub, where all the data comes and is re-engineered, refined, and exploited. And we have based the development of the Pixel platform in 5 ways, developing different agents and different components in order to gather and analyze the different data. So the pilots that the ports that we have involved in the Pixel proposal are the port of Monfalcone, a small port in the north of Italy, the port of Bordeaux in France, and the port of Piraeus and the port of Thessaloniki in Greece. The port of Piraeus and Thessaloniki will exploit the concept of port city integration, the port of Bordeaux, and energy management use cases and the impact in the environment, and in the port of Monfalcone, the intermodal transport use case together with different stakeholders within the port. And we have the environmental index use case that is transversal to all ports and has been implemented in all of them. So this is, for example, how Pixel looks like. We have deployed different environmental sensors deployed in the different ports. We are gathering the data and we can see them in different places. This is one of the aspects of one of the screens in order to measure what is the port environmental itself impact and the port environmental index and the different data that we are gathering in the dashboards. We can also see the different information regarding the berthing of the ships and the different information of the impact of the different ships and the different elements that are within the port. So all the data is exploited and all the data is managed in the Pixel platform. So this is, for example, the operation of Pixel in the port of Thessaloniki and the different data that is appearing and the different screenshots and has been integrated in the operational tools that are being operated by the ports. So this is the presentation regarding the exploitation of data of Pixel. You can find more information about the different aspects in the website and in the social networks of the project. So, Andreas, the floor is back to you. I hope
Excellent. Thank you very much, Carlos.
I think it has been tied to 10 minutes.
Perfect. On time. Excellent. Thank you very much. And let me use this opportunity for the audience to post any questions you may have to Carlos, be it clarification questions or other questions you may have that could facilitate the discussions later. So thanks again, Carlos. Looking forward to the discussions. Okay, next in line would be me again, wearing now my hat as the kind of ex-technical coordinator of Transforming Transport, but also looking a little bit forward into the DataPorts project, because we kind of continued our work on AI-based solutions also in DataPorts. And what I picked here is a pointing case showing how data-driven AI could really help to improve terminal process management by bringing predictive and prescriptive analytics into the field and really helping the port operators to improve their daily work. So the background on the project, just in a nutshell, this was Transforming Transport, one of the lighthouses, one of the first 2 lighthouses in the Big Data Value PPP, a very large entity, a very interesting entity. It was lots of fun to really understand the problems in the transport domain and map them with ICT solutions from the other side. And here you see some of the success stories in the different sectors we looked at. And this presentation here obviously focuses on the ports side of things, where we aimed to increase the efficiency of port operations by providing decision support to terminal managers. Let me start with a motivation from one of our key partners here. So overall, Transforming Transport had 13 different pilot sites, and one of the pilot sites was the port of Duisburg in Germany, one of the largest inland ports. And their problem basically is that with increase in transport volumes, definitely before the COVID period, they could not really capture all this growth in containers that went into the area because they couldn't grow in size. So an obvious need was to be more efficient, to increase the productivity and the throughput of the terminals. And this was met by a huge trend that we had an increased availability of data because all of the terminal equipment has been started to be digitized and instrumentalized. So here you see an example of all the things that go on in this terminal. This is a bimodal terminal with trains and trucks, so no sea, no port. The port is the terminal next door. But all of these things are completely digitized. So you have data streams from all these moving vehicles, from the cranes, from the trains, from these reach stackers. So everything is kind of visible in real time. And this allows you to do the typical descriptive data analytics. For example, this is an example where you can see the frequency and the number of containers per area, and you typically see these hotspots, but you also see areas where there may be improvement for efficiency by putting some more space into use. This was not the thing which we addressed. We really wanted to better understand how we can do prescriptive and even predictive and even prescriptive analytics. So we use this data in real time to facilitate better decisions for the terminal operators. And this leads us to the AI-based solutions. And the idea in a nutshell is that assume you have this terminal process running here over time, right? So you have the transport of a container. You are at some point in time and you want to understand whether this transport will be successful. In our case, we wanted to see whether the containers are loaded onto the trains in time so the train can leave the terminal on time. So what you can do with AI-based solutions with machine learning is, of course, try to predict the future situation. And if you see there may be a problem, a violation, a delay of the train from the terminal, you may proactively intervene and try to change the running process, add more staff, reschedule things in the terminal to make sure you can meet the deadlines for the trains. When you want to do this, there's two interesting requirements for this predictive analytics and decision support. The first is, obviously, you want to have high accurate predictions. You don't want to have the terminal operator to base his decisions on wrong predictions. So if you have a false violation predicted of the time, you have unnecessary interventions, which cost money and time. And you have false non-violations, which means you miss the chance to do something for a problem. Unfortunately, the earlier you are in the process, the lower the accuracy of the predictions. Or I can show this here. So you may want to wait a certain point in time until the accuracy of the predictions reach a certain level. As you can see here, it takes some time until you are pretty sure what happens in the process because you collect runtime data for that. But this means the later you are in taking the decision, the less time you have for these interventions because you have some lead time in order to make things happen. Like if you increase the staff in the terminal, it may take 3 hours or so after notification until the staff is really operational. So the solution was to use a deep learning approach, which kind of allowed the operator to take a trade-off decision between the accuracy and the earliness by providing high accurate predictions. So the idea here was you don't use just one prediction model, you use an ensemble of prediction models, which by themselves increase the prediction accuracy. But the key kind of decision-making element we provided was a so-called reliability estimate that gives you the probability of this machine learning box that the prediction is correct or not. And with this, we could provide the terminal with a dashboard, which we call the terminal productivity cockpit, where you see all these different trains and the loading status of the containers. And then you get also a prediction here that tells you the estimated time of departure based on your predictive analytics, including a probability that this prediction may really be correct. So you can take this into account for decision-making. And like in the typical weather forecast, today you can say, okay, there's only a 69% chance that it's delayed by an hour. Maybe I don't trust this prediction and rather hope for the best. Right? This is just one example. This is where we stopped in TT, and the results were already quite impressive. So we were almost improving by 5% the terminal efficiency in terms of how many trains can leave the terminal on time. But of course, one problem is that you do not really know what's a good probability. So is 69% a good probability, or should I wait until 80%? Yeah, and depending how you set this threshold, you have again earlier or later predictions, or more accurate or less accurate predictions if you wait. And this is where we thought is an opportunity for yet another machine learning approach. And this is what we elaborate in the DataPorts project. This is where we bring into reinforcement learning to really move from predictive analytics to prescriptive analytics, where we have this reinforcement learning box. Technical details may not be so relevant, but we use a neural network-based approach here. And this reinforcement learning box really tries to learn over time what is the best decision in which situation, take into account the predicted delay or deviation, the reliability estimate, and where in the process are we. And then this box basically tells the operator, you should do something now, or you shouldn't do something now. So really kind of have an advanced decision support. And again, the results are quite, let's say, promising. What you see here is a benchmark data set, not from the port anymore. It's a research data set we used. You see here with all these curves, the learning behavior of the reinforcement learning agent. The red stuff is the reward. This is kind of the variable that the reinforcement learning agent tries to optimize. You see then a trade-off between the earliness and when I do an intervention. And the interesting point is actually here the rate of correct intervention decisions. So how often was the reinforcement learning box correct in telling the operator, now you should intervene? And you see then over time the things improve. And the other interesting thing you can see here is that there may be some drifts in the data. You can see this here, that the prediction accuracy really can change at some phases here in the process, or these are many processes, sorry, because the data may have changed over time. And the learning can also really accommodate this over time. So you really have now the situation that even if the operator would have learned what is a good threshold to react on this reliability estimate, because of data drifts, this threshold may have changed because it's not calibrated over time, and this reinforcement learning approach can capture that. And in this data set, we were able to really improve the costs if we take into account wrong and right decisions by almost 28%, because we really had these drifts here that were really accommodated versus if you would set an optimal threshold based on some subset of the data. So this was very promising and all very nice. Now a little bit some lessons learned, and maybe it's the backflip of this story. And I think this could nicely lead over also to the data sharing spaces discussion. So the first thing is that in order to get there where we are, data integration, data understanding, cost us an immense amount of time. So we estimated that 80% of the time from this nice little instrumented terminal you saw at the beginning until you saw the first heat map, and we used this for prediction, took 80% of the development effort for various reasons. You have inconsistent events, inconsistent timescale, inconsistent coordinate systems, and many, many things. The most nasty thing was that you had a database with lots of data about the cranes, and they decided to change the contents of the columns in the database, but didn't change the schema. So you were completely unaware that the contents is now a completely different one. So obviously a huge opportunity for these data platforms we will be discussing during this session. The second thing is that you saw we throw maybe all the kind of state-of-the-art and en vogue deep learning stuff at the problem, which is very nice because oftentimes these things work without extensive hyperparameterization. You basically do the automatic feature encoding and all these things, but it's a really kind of huge demand on compute resources. So training one of these deep neural networks we used for the terminal took even on a CPU, strong CPU computer, a day or something, because it was a huge data set with very long running processes. So this is a point, I don't know how much this is being discussed in the data spaces, that we may also need compute resources as part of these data spaces and not just data integration facilities. And the last point I think everybody experienced that too. You have this garbage in, garbage out effect. The data we started from was not really created for the sake of predictions. It was just there because the equipment manufacturers thought it would be nice to have access to some of the data or use it for some maintenance purposes. So we realized if you really want to do some next level of improvement, you also have to think about data collection that is fit for purpose. And with this, I like to conclude with a pointer to an interesting book we have written in the BDVA setting, which brings together all of these experience from different application domains and sectors together. It should be available soon. It's a Springer open access book. And one of the sections or one of the chapters also covers the lessons learned we had in transforming transport with much more detail if you want to use this as a reference. So thank you very much. If there's any questions, start typing them away. And with that, I'll give the floor to our last speaker in this first kind of cluster of presentations, which would be Vivian. Vivian, floor is yours.
Hi, yes. Let me share my presentation. Okay, hope it's visible by everybody.
Perfect.
Hi, my name is Akribi Vivian QC. I belong to Intrasoft International. I'm the head of the Transport Lab for research. Here I have a dual role since I represent also the subgroup in Big Data Value Association for mobility and logistics. The scope of the task force is quite expanded, I have to say. A lot of us are brought together in order to identify topics related to data for mobility and logistics, as well as trends and mega trends that can influence in a sort of a way the forthcoming EU research programs. And not only, also commercial contracts. So a lot of companies which are on board in BDVA, they are thirsty for knowledge sharing and for business curiosity. They try to get involved and see what is happening there. Also, one issue for the existence of the task force is to create several discussion topics and exercises and preparations for big events, as well as a call for contributions and find the gaps in the several work programs that exist by the Commission. Of course, the main point here is to place the customer, all the targeted stakeholder experience as a key factor. And why is that? I'll take you a little bit back because how this got initiated. Transport is a very big domain having underneath 7 subdomains. It's the Europe's ever-growing mobility and logistics sector, part of the main issue for a springing economy. So what we have seen, especially lately, is that there is no doubt that the transport and the logistics sector that is undergoing an important transformation. And why is that? Because new technological solutions are coming up in an everyday use. People are asking for more, demand for more, they want the change. And all these are driven by an audience, which is never ending. Audience requesting more and more, and also by a market which is looking at trends. And these are sometimes blocked by unexpected challenges. This one, the COVID also was one of those. So as you can see, at no point in the recent history, we don't have witnessed such a large degree of political, economic, social, technological, and legal changes that are influenced this segment of economy, because it's one of the main reasons for the economy boosts. We have to concentrate a lot of, let's say, ideas and innovations in order to assist the growing economy. Now, initiating this discussion started some years ago. We wanted to cover several subtopics that I have tried to list here for you in an explanatory manner in order to assist the way that this group is thinking. One of the main targeted points was the trip. We focused a lot on the traveler. Some of us and most of us we want an easy trip from A to B. So this is what we call initiating all the ideas, putting everything on the table for perfecting it, the complete trip. This is how we called it. Under this trend, ideas that you might have heard, such as MaaS, mobility as a service, shared mobility, personal mobility, on-demand request for services, integrated multimodal transport solutions, and ticketing as well for urban and long-distance journeys, they all come under this group. Now, on the logistics, because this particular domain is quite broad and it has a lot of challenges and a lot of interest as well due to the different types of stakeholders involved and the different investments at stake, we wanted to pay, let's say, very much attention on several aspects. So we investigated the use of micro-hubs with local package transshipment facilities and crowd shipping for last mile deliveries. The discussion went also to the physical internet, particularly focusing on e-commerce and urban logistics, and on the data market for collaborative logistics, ledger technologies, big data analytics, and also the potential of IoT, the Internet of Things, to track inventories. And this actually is something which is quite proliferate also in several places of the work program. We also had a thorough look at the automotive part. Here, we also included electric, connected, autonomous vehicles since the very beginning of the subgroup. Now we have a different branch also totally devoted into this discussion in collaboration to different subgroups. That one that is led by AVL. Together with this one, we're trying to see how typical ameliorations and challenges can be tackled, especially also in this domain. The most important thing, though, deriving from this group is that since there is a complexity for modern transport and logistics, and this is growing daily, it's more and more difficult to understand what should be the short versus the long-term focus and in what to invest in. This is why this particular group tried to make an attempt to identify key forces transforming the day-to-day in the transport sector. So this has happened through different subgroup exercises and big events where we tried to collect different types of contributions that led to ideas relevant to, for a start, digitization, for example. There we discussed on how to devise completely new business processes and models, included integrations across the value chain. Digitization, it seemed that can be expected to reshape the way that the consumers interact with business. And this was a very interesting, let's say, observation, which is kind of visible already in online and mobile ordering of transport, especially this has been observed from the ones that are really focused on this particular type of research. And this can range from personal transport services through taxi services to car sharing, but also encapsulates the public transport ticketing. Another trend was the machine-driven process changes relating to automation of manual cognitive tasks that are either routine or non-routine, and we have seen several H2020 projects there that came to present also into the BDVA events that they were tackling this particular point. But this generally, as an idea, does not involve new ways of doing things, but the focus is on automating the existing tasks of the process. Also, we are looking with interest at the warehousing robotization with different types of facilities, drones, AR, VR. So we've seen several tests, and we are following up on the challenges that our researchers have registered and shared with us. But also we looked on last mile delivery optimization. This was also being a hot topic for quite many years now. Also, an important note is the software-driven process changes. There we looked on blockchain, big data, predictive maintenance, and artificial intelligence solutions. Also in the changes in the market's domestic commerce, where it relates to big business entering e-commerce and sharing economy solutions. Electrification is part of the greening aspect as well, and involved also in the green agenda. And sustainability, so two important keywords that they were quite, let's say, substantial in the Green Deal calls. We've seen an expressed need from several stakeholders, inclusive the cities as well, for data-driven modeling and impact assessment of future integrated mobility and energy solutions, and is an emerged need to consider spatial and urban planning in new urban mobility infrastructure setups. What's been very important and has been also supporting by specific slots in about a year ago in the BDVF was the policy design support. It's very important to focus while we're thinking of new coming ideas and frameworks to implement, to also see what are the new data-driven tools for policy design. We need advanced methods for monitoring, assessing, and analyzing mobility energy solutions in line with evolving societal needs. Also, new concepts and variables are also required to model smart, connected mobility systems and stakeholders. And also the new data-driven benchmarking to evaluate smart electric mobility solutions efficiency. All these are assisting in a way the acquaintance of the several topics, especially from public authorities, because at the end, what researchers and industry can do, they can suggest ideas for policy recommendations. They can do suggestions. In order for new policies to be implemented, you have to share knowledge and create awareness to the local authorities and have the local support and make them feel on their comfort zone. Generally, this is how the things are far easier to be done. A very important topic not to be forgotten is the AI one. Coming from this particular domain 25 years ago myself, it's coming and coming again. So we are moving from siloed solutions to an AI ecosystem of excellence and trust. We've seen AI in deep learning and logistics and public transport, discussions on automation of manual cognitive tasks that can be routine or non-routine, customer experience improvement through digital assistance. This has been also a topic for quite many years now. Optimization of operational efficiency through predictive analysis of mobility demand, autonomous dispatching and operations to better meet the increased demand and dynamic environmental changes, and generally AI applications for improving driver safety. Projects like Trustonomy we've seen here that are following the BDVA things, AI applications for optimizing fleet management, quite many projects there. We touched slightly also some ideas also into AI for identifying mobility patterns and consumer behavior that are changing. All the three mass projects that have been awarded, Optimum and several others that have presented through the years in BDVA. Also very important is that to note is that we focus also on common mobility data space aligned to the EU objectives to support sustainability and multimodality. This should function in synergy with other key systems. So this is something to have in mind, and this is why this particular subgroup is keeping an open dialogue between different types of domains, because this is an important requirement. And closing up is after showing you a bit what we have highlighted on the different trends is that you're all welcomed to join the subgroup. We try to put together experts for bringing innovative know-how and creating the necessary collaborating environment. we've been a bit slowed down by COVID, but now we are kicking new exercises, starting to prepare on a BDVF with new ideas and new contributors. So we want to put the seeds for the new task force roadmap. We want to identify that was not touched from the previous research examples, and let's say put the stone for the new coming ideas, not only for the research programs that they would be published in the future, but also to be proactive for calls for tender, because there are a lot of companies who follow the task force developments, and they have different needs and different requirements. And as I said, the very center of all is to keep the stakeholder, the customer happy, and learn in a way to do rework. Challenges will always be there. We have to try and put our bents and our powers, all of us, on the table, and learn to rework and utilize all the things we've learned so far.
Thanks a lot for that.
Thank you, Andreas.
Thank you. Very, very broad view of things, and everybody's invited to get in touch with you if you want to engage in this subgroup.
Anytime.
Logistics. Thank you very much. With this, we close our first kind of block of looking at opportunities in transport, more from the kind of application, maybe services side. I haven't received any questions so far, so please, everybody, if you have questions, please post them. But as we don't have questions, we can, of course, now move to the second part of this session here, which would be looking at more concrete architectures, building blocks, maybe the more technical side of things. And our first presenter will be Angel, and he will present the ASSIST-IoT project. Angel, the floor is yours.
Thank you very much, Andreas. May I ask you, please, if you could see my screen?
Yes, very good.
Thank you very much. So first of all, thank you very much, Andreas, for the warm introduction, and also my colleagues for sharing such promising KPIs, and also to the organization, because I think that setting up such kind of spaces is good enough in order to share ideas, because as we could see, there are some kind of commonalities among projects. My name is Angel Martinez, as you said, Andreas. I'm a telecommunications engineer. My pleasure to play the role of innovation manager in ASSIST-IoT project, which is a project we, let's say, not just has started, but we have between 6 or 8 months ago, started 6 or 8 months ago. And my player on a daily basis, I'm product manager in ProDevelop, which is a SMA located in Valencia, Spain, where our core business is to develop software services for the maritime industry. Starting specifically to the presentation, I would like to start talking about the origin, or at a glance, which is the scope of ASSIST-IoT project. As we have been seeing, it's quite recurrent when a company like the one I play or I work tries to set up a new service or application in a complex environment, which is, for instance, a port ecosystem. There are several ICT systems owned by different companies, where normally it's quite common that they don't talk or share some kind of information among them. So it's very difficult to set up or create some new services taking advantage of such kind of infrastructure. And also, I would like to say that for the stakeholders which are consuming such kind of information, is not the optimal way to take decisions or to take better decisions, because there is not one source of truth. So I would like to highlight that there's a common problem, which is we have a huge amount of data, but there is a vast heterogeneity of such data, and it's not so easy to take advantage of such kind of huge volumes of information. As normally in the startup world is said, I mean, with a necessity comes up the opportunity, and that is the gap that ASSIST-IoT is trying to cover, to fill in. Also taking into advantage that the stakeholders are demanding some kind of new services, for instance, where delay or latency is not admitted. So the only way, as we could see and understand, or the next step in order to try to fulfill such kind of feature or specification for such stakeholders is to try to move all the data which now is deployed or is pushed into the cloud closest to the origin of the data, which, as you know, Andreas, is called the edge. So, in one word, the intention is to avoid such kind of centralized ecosystem of platform or IT platforms, to try to not to push the data, but to make such kind of figures and estimations very close where the data is produced. The main goal of this project, research project, is to create such kind of new architecture. And if I would like, or if I have to resume yes, to resume the goals is, we are not, even though we have to demonstrate the application and the ecosystem in real environments, we are going to talk in a minute about that. The intention is to deploy or to put at the disposal of the industry an agnostic technology which they could take advantage in order not to try to start once and again from scratch if they have to, or they would like to take advantage of this new approach where the data will be estimated not in the cloud but in the edge. As we see this, the point is that we would like to put the disposal of such kind of companies or entities or stakeholders all that kind of technologies, so that rather than to try to create once and again or to solve always the same problems, the point is that let's give them a core infrastructure, universal, open, and so on, and a standard, of course, so that they could put the focus on the business, in the service that makes the day for the clients, rather than to start reinventing the wheel once and again. As I told some minutes ago, we are going to validate the technology in real environments in a very challenging one, which are let's say the automotive, the building, and the port automation. If the audience would like to know more details about that, here and is the link with more details and people to keep in touch in order to have better understanding. But for the sake of this session, I'm going to put the focus right in the port automation one. As we can see in this image, more or less, or where all the operations or most of the operations in a container terminal happens is in what is said the yard area. In this part, which is in the land, let's say, is where all the, I would like to say, the magic of ASSIST-IoT will happen. All the demonstrators that we are going to try to deploy will be carried out here. I think that it's important to mention here that, at least for the audience, that the business of the terminal containers, the container terminals, is to move boxes, where all the goods and services are translated from one place to another. As you could see in these figures, is the growth of the number of tons of millions managed by container terminals. We have only data for 2019. In 2020, we have had the COVID, and the situation is a little bit worse for obvious reasons. But if I would like to sum up or to summarize this slide, is that most of the cost of the terminal containers is based on operations, in the operation that is. So this is a very good point in order to try to improve or to have a better effectiveness in the terminals. I would like to, well, the challenges are quite similar to the ones that I have told at the very beginning of the slide. So I would like to take advantage that one of the points that we would like to solve is that it's very difficult to establish machine-to-machine communications. And it's even worse in those situations where the machines or the stakeholders comes from the street. I mean, they are not part of the terminal operator, so it's very complicated for them to share data with people who comes from the street, like the road and tracks that we have been talking before. The scenario will be managed by the companies, the testing scenario, Terminal Link, which is the owner of the terminal in Malta, Cranes, which is a cranes manufacturer, and ProDevelop, which I have I told before in the introduction, is an SMEA located in Valencia, Spain, and we are a very good company in order to carry out integration of technologies and services. The scenarios that we are going to test in the terminal in Malta, taking advantage of the ASSIST-IoT technology, is very brief, but we are going to try to develop a system in order to track assets in the terminal yard, mainly containers, because we really know for the feedback that we are having from our clients that is a very point or a challenging issue that is worthy to be solved. The second one is to reduce the idle time that normally they have when they will have to position trucks and load and unload the container. Now is almost done manually. Our intention is to reduce the complexity when a truck which comes from the street needs to take one container and in the opposite, to solve such kind of machine-to-machine communication in order, as I have said before, to reduce such kind of idle times. And last but not least, figures show us that 60% of time there is an idle time when a manual operator manages a crane. This is not because of the lack of efficiency of the project, but of the job done by the staff, but the type of job, which there are some stops, etc., which forces the crane to stop. So the point that we are going to try to demonstrate is that the opportunity to remote manage operations, so that when a process stops and needs to wait for the next container or is waiting for the next truck, the operator has the opportunity to match simultaneously another crane, so that the show still goes on. And this is at a glance the whole picture, sorry, where all the scenarios will happen. And the point is that our intention is to take advantage of such open architecture, which will enable us to reduce the idle times and latency and produce better services, not only for the terminal containers, but also for the whole port community industry. So that's all from my side. Thank you very much for giving us the opportunity to stay here. And it's more than welcome for the audience to ask anything. I will be more than happy to reply. Or if they would like, or communication channels or social media is more than open for them. So thank you very much.
Thank you very much, Angel. Very nice presentation with interesting insights of what could be possible from the IoT. And I didn't realize so far from the edge point of view, which could also trigger some of the discussions towards the data spaces and what the features is that they should offer. Thank you very much again. Moving to our next presenter, it's Fortis, who will present the SmartShip project point of view.
Yeah. Hello, Andreas. Good evening to everybody. I'm here to present SmartShip, but first I have to share my screen. I guess you will see the screen now in presentation mode. So let's proceed with what I would call a Horizon Europe project that actually support the trend of maritime in digitalization and decarbonization, a huge trend nowadays. SmartShip is a project with a duration of 48 months. Due to COVID-19, we have just granted recently an extension to 60 months. Has participated of 7 organizations from 6 different countries. We coordinate Danao shipping, so we're coming from the industry. itself, and it's a typical Marie Curie program. So in a sense that the research is consumed and produced through interactions from multidisciplines, researchers from different organizations through secondments, as you probably are familiar with this concept. Speaking about the consortium, I already said that we are lead project, we are done our shipping, we are managing container ships in the business, and we have a rich background in the EU program research. ITML, a Greek company, which is actually dedicating data analytics, Epsilon, with quite a huge experience in maritime business again. ENPC got the POM Paritech, which is actually specialized in circular economy, a main concept of our research. Bluesoft from Poland, which is actually specialized in the cloud computing, Technical University Braunschweig, in cybersecurity aspects, and last but not least, Harokopio, and an academic organization, from Athens that actually has a lot of research in computations and optimization of algorithms. So what we are aiming to produce in SmartShip. We are even though we are a Marie Curie project, and Marie Curie, as you probably know, is about secondments and interaction and research and gain, knowledge through, interactions between different researchers from different disciplines. We aim to create a product that is based and enhancing existing state-of-the-art technology, existing systems that we operate in Danaos, and in order to digitize and support digitally decisions that are taken on board and on shore. So we will create the data analytics decision support system, and we're going to try as a novelty to embed the circular economy principles in order, let's say, to produce less carbon footprint through maritime operations, and one comes after the other. I mean, if we go for optimization of energy efficiency, that means that we will consume less fuel and we will emit less emissions. We're going to do that, just you're looking at that picture, by sourcing data from different sources, either from legacy systems in our company or from external factors, as the weather forecast, which is actually a very critical factor when you're plotting your voyage in a maritime business, or from any other, sources, external sources, or through IoT technologies with several data points on our assets, which is the ship, computing that on the edge, on the fog, on the cloud, but visualize it in the cloud repository visualization tool, where it will be both consumed any decision support, let's say, system itself, either ashore from the personnel that take decision at the office and on the ship. And we're going to try to do that by moving from a linear, let's say, perspective, where we, in terms of maritime, where we design our asset, build of asset. When we're talking about asset, I'm talking about ship, operate, reach, let's say, the end of the lifetime, and do a scrap and dismantle the ship and maybe recycle some of the iron, to go to a more, let's say, circular by design operation, where we explore data, but we try to find a way to reuse data, where we prolong the asset because we try to exploit data in order to reach predictive, let's say, maintenance, or before troubleshooting, to spot, let's say, the defect and intervene right from the beginning in order to prolong the efficient, let's say, life of the asset or the machinery. We are trying to find ways in order to accommodate, let's say, the principles of the circular economy. Let's outline the objectives of the project. So we are trying to see what are the needs of the market. And the needs of the market nowadays is actually to reach decisions that will help, let's say, the ship owner to comply with a very, very, very high regulated shipping environment, especially what has to do with emissions. How are we going to do that? By exploiting, different perspectives and different research, let's say, capacity and legacy from different organizations in different aspects, again, to IoT, to data analytics, to decision support, to optimization algorithms. We're going to design a tool, a data analysis and decision support tool. We're going to embed, as I said before, lean management, circular economy, circularity, let's say, in the decision making. We're going to offer a multi-layer holistic, let's say, architecture of the system. We're going to demonstrate system effectiveness based on real-life use cases. I'm going to talk later on about these use cases that we depict and are quite critical in marine environment. And we develop, let's say, a new long-lasting research collaboration since we activate research from different disciplines, from teams and organizations, both from academia and the industry itself. This is our architecture, a basic schematic of our architecture, a multi-layer, as I said before, architecture. From the bottom, where we do the sourcing of the data, either from external sources or weather, or from sensor and acquisition data from the machinery and the hull of the ship, legacy system and historical and training data from the shipping company itself. The second layer has got to do with how we'll embed some, smart algorithms, how we will do the analysis of the data. We try to explore neural networks or mixed in a fog computing, let's say, or in a more, let's say, gray area, not a black box, trying to not be like a black box of neural network, but we embed the decision making and the flavor, let's say, of the expertise. And then how will this support our decision, digitalize the decision, both ashore and on the ship, and how will this populate it in a web-based platform to be consumed, as I said before, both at the ship and from the office itself. And we will try to make some proof of concepts out of this architecture based on existing tool of Danaos and applied it in different use cases. I'm going to speak later on about this. And we do that by try to fertilize knowledge both from the technology partners and the industry and, of course, the academia. So if we move forward to use cases, we try to depict these two critical, let's say, operations in shipping. One has to do with the voyage planning and monitoring. When we're speaking about voyage, we're speaking about coming from point A to point B, from a port to a port. And we try to digitalize, let's say, and assist master on the decision making. Weather routing is quite, has a long history in shipping, but we're trying to make, let's say, the decision multi-objective. So not try to avoid the bad weather, but see how we reach the point with a route decision that will actually come up with the least, let's say, carbon footprint, or you're going to go on time without waiting in anchorage, and we try to do that, but by and large, let's say, the data points, not only the weather, but the model of the ship for the least, let's say, resistant addition, for the emission factors, for the machinery modeling. We try to complete, let's say, the decision right from the beginning up to the end, not only see the planning, but how we execute the decision, how we monitor the decision, to look upon on aspect of performance of the voyage, and so on and so forth. The second use case has to do with the condition-based fleet maintenance. So we are moving from a planned, let's say, maintenance where you see the manual of the machinery and you activate, let's say, some predefined aspects of maintenance of the machinery, to a more, condition-based. So we are going to do and apply data acquisition points in different data sources from different sessions on board, from the machinery, from the main equipment. So to monitor, let's say, the performance of the asset itself, and try to predict try to identify partners, try to see how this the operation of the machinery is beyond or over or a predefined threshold to create an alert mechanism in order to troubleshoot before actually the breakdown happens. And both of these cases, we try to embed, let's say, circularity in thinking, because we're not going to go and see the voyage from the planning, but we're going to see the voyage in a micro scale, let's say, from planning through execution and monitoring. And we're not going to go and monitoring the machinery by design, but we're going to follow and monitoring from the design to the execution and to to the operation, and maybe we going to embed, as I said before, circularity in the design, in circular economy, by looking at the reusability of the asset itself, prolongation of the asset, and the efficient outcome of the asset, even we speak about the machinery, the hull, or the whole vessel itself. So as a takeaway message, what is our principal outcomes? To organize knowledge exchange in the field of IoT and advanced data analytics, to look at the state of the art and be dynamic and comply with all the regulatory in the shipping industry, to design an IoT based, we're going to produce a tool, as I said before, on data analytics, to see a multi-layer optimization tool from data sourcing to data exploitation, data processing, data computation, and visualization, and doing all that in an integrated framework. And this concludes my presentation.
Excellent. Thank you very much, Fotis, for this insightful presentation. And I like very much this circular economy aspect, which I think is something really not so visible elsewhere. Thank you very much.
Thank you, Dres.
So this means we'll move to the last speaker in this second cluster of presentations, and floor is yours, Santiago.
Okay, thank you, Andreas, for introducing me. So my name is Santiago Cáceres. I'm project coordinator of DataPorts, and in this 10 minutes presentation, I'm going to briefly introduce the project, and I will mostly focus on the architecture and the building blocks that we are currently working with. And I will try to finish with a small summary of our use cases and the challenges, and some challenges that we have ahead, so we can have some discussions, hopefully, at the end of the course. So DataPorts stands for the data platform for the connection of cognitive ports. And what is exactly DataPorts? Well, what we want in the project is to take advantage of the huge amount of data generated in the European seaports. So there are already a lot of stakeholders working on a daily basis in the port. They all manage their own ICT infrastructure, IoT infrastructure, and so on. And we believe we can exploit even more than it is now, all this data to generate valuable information to the different stakeholders in the ports. And how do we achieve this? We make this thanks to an industrial data platform that we are building inside the project, where we plan to combine different data sources from the different stakeholders in the port with the final aim to improve the existing processes. So logistic processes, transport operations inside the port, etc. So this is our main final aim. And on the top of that platform, and for the users, we are building what we call cognitive applications. These are artificial intelligence-based applications. So the decision makers in the port can make predictions, can make plans based on factual data and based on these applications that will provide them insights about what's going on in the port. And finally, if we introduce such a new tool and applications, this will enable new business models. So we are also doing some research about how to take maximum benefit of all of this and how each one of the actors in the ports can take benefit out of it. Okay. So what is our data platform? So I will put a very easy example on how this will work at the end. So this is not the final aim of the platform. This is just an example to illustrate and to give some insight about how this is going to work at the end. Okay. So just imagine we are in a port and we have a couple of stakeholders there, which can be the terminal operator and the container carrier, that they need or they want to share some information about the container with the port authority. And this information is going to be later on processed, and the port authority plans to provide some applications, artificial intelligence based or not, to other stakeholders inside the port. Okay, so the terminal operator and the container carrier will act as a data provider in our example, and they both will have some kind of instance of the DataPort platform on their premises, on their system. So we follow the approach of data has to be as close as possible to the owners of the data. Okay, so the data consumer in this case is going to be the port authority, who is going to consume all the data coming from these two actors, and they plan just to gather and to build some cognitive services. So probably they want to make some prediction, for example, of the estimated time of arrival of the different containers. and they want to build some models with the platform. So they don't have the knowledge inside the Port Authority to do this, but they can rely on an external party to provide all the machine learning algorithms or the technology that they want to provide this cognitive service. So this IT provider, which can be outside of the port, it's also part of this data space. We have also some instances of the data platform in the premises, and will provide these mechanisms to the Port Authority. So this all has to be wrapped up with some data awareness rules, of course, of who can access, what data can be accessed, and so on. And this also has to be a secure environment. So we have to provide trust to the end users. We have to show that we take into account security. Okay, so this is how a possible use of our platform. And you see at the top of the slide, the industrial data space logo. It's because where we have been developing our architecture, we didn't start from scratch, of course. There are many data platforms already there and projects dealing with this. So we consider the industrial data space reference architecture model to be a good approach to be followed. And for those of you who are familiar with this reference architecture, so we are following what they guide. So in this architecture, you have some functionalities that are needed for you to build some data space, and there are some guidelines on how to transfer data, how to exchange metadata, how to provide apps, services, and so on. So we follow this approach. So now going to the architecture that we have envisioned in our project, and we will make a reality by the end of it. We have these three main building blocks in our architecture. You see the data sharing services, data governance services, and data analytics. Okay, so I will go into details in each one of them of what the platform is providing. So you can think on this as boxes that are modular, and you may need it or not. You can install everything or just parts of it. So at the bottom part of the screen, you see the data sharing services. So this is the layer which is closest to the data sources. We have data access agents, which will be the mechanisms for data acquisition of the data. And then we have the semantic interoperability broker, which will provide a common schema for all the data sources. So everyone who is inside DataPorts platform will speak the same language. We have also virtual data containers. These are storage mechanisms, big data mechanisms, distributed storage of data, etc., to facilitate the data sharing services. And one, I believe, innovative things is the blockchain network for data sharing. So we offer the possibility to directly share data through in-chain blockchain network. Okay, so not just using blockchain as a data governance rules and setting up rules and so on, but also to use it in-chain mode. Okay. Then we have the data governance services. This is a complete block that is enabled by blockchain technologies. We are using Hyperledger Fabric here. We have the clearing house, where we keep track of all the logs of the system. You can imagine if you are trading data, you need to know what's going on in the platform. We have the IDS broker, which is basically a catalog of metadata. So you can look the data you are looking for, and you can check who has this data that is interesting for you and just get in contact. And we are using smart contracts for governance rules. So basically just to say, this is my data. It can be accessed in this way. It can be processed in this way. This is the period where you can use it, etc. This is all enabled by the smart contracts for governance rules. And finally, the data analytics. This is all related to artificial intelligence enablers modulars. So we have process-based analytics, which has been nicely presented by Andreas in the Transforming Transport first presentation. This is a continuation of the work carried out in Transforming Transport. And we have other technologies which are enabling artificial intelligence applications. And on the top of the platform, we are putting the IDS connector, which wrap up the services and the components that we are using and expose those to the outside world. Okay, so that would be our architecture on a very high level view. Okay, so just very quickly about the use cases. We have a total of 2 use cases plus a global use case. The first one, it's the Valencia port use case. This is the tracking of transport operation. We are also planning to enhance the port community system of the Port of Valencia with some analytics services. We are using mainly the blockchain capabilities of DataPorts platform for sharing the verified gross mass of the container. So this is a requirement that is coming now, and we put a mechanism so everyone can share this, and some digitalization of the consignment nodes inside the ports. Okay. Then we have the Thessaloniki port with another use cases. The first one, data-driven app for strategic and real-time decisions. This is mainly due with something that we have here also today in the workshop, the environmental impact of all the traffic and the thing of having a port city all together. So they want to have a clear view on what's going on and how can redirect traffic and so on. Then we will have mechanisms for permit ID for container pickup for the hauliers, for the trucks. Then some queues prediction, facilitation of passengers, professionals, and visitors. Okay, and finally we have a global scenario where a couple of partners are providing technology to show up that our platform can easily scale and show some interoperability and show the interoperability out of it. Okay, so just to end my presentation, some challenges that we are facing in the project, but also I believe are common for everybody. Is and we have heard in the previous presentations also, just to emphasize those, the data heterogeneity. So there is a wide array of information systems and that's infrastructure using ports for regular business processes. These are very heterogeneous in terms of quantity, quality, format, and so on. That's something that we have to deal with. I think one of the most important ones is how you build trust with your end users, how you put mechanisms, security, and so on. So you guarantee the information is secure and they trust the platform, otherwise no one is going to use it. We are investigating data trading using blockchain. This is a technology emerging in the transport and port domain. There are good examples of it. This is TradeLens. There are others. So we also are investigating there. And last but not least, also mentioned in this workshop previously, is if we want to have accurate cognitive services, we need a high amount of quality data, and otherwise, as Andrea said, garbage in, garbage out. Okay, so that is this is my very quick overview on the DataPorts. So if you have any questions, I will be very happy to take those in the questions and answers slot. Okay. That's it.
Brilliant. Thanks a lot, Santiago. Very nice. And with this, we close the second cluster of presentations and now move to the final presentation for this session, which is towards the European data sharing spaces. And Tomo, I think you now answer all our problems and challenges, I hope. Yeah. Or maybe not. Floor is yours.
Yes. Can you see the slide?
Not yet.
Not yet. How about now?
No.
Let me try it again then. On screen, yeah, it works, and now I'm doing the sharing.
I think now we see a screen, yes.
Yeah, okay. Here you are.
Super, great, excellent.
Very, very good. So thank you very much for the wonderful presentation and talks, and that really shows that how like wide area this data space is, and these all kinds of heterogeneous approaches and so on. So yes, good afternoon. My name is Tuomo Tuikka. Yes, and I come from BDV Technical Research Center of Finland, and I'm also co-leading the task force on data spaces in Big Data Value Association. And some words about the task force first. And it used to be a subgroup earlier, but then we decided that thought that it's in fact really like emerging a big issue that the data spaces are becoming and forming now, and we look forward to see that what kind of issues there are that we have to take into account in the future. And Now, at the moment, the task force subgroups are either joint subgroups with other task forces, like verticals and data governance and standards, and it's very important to get that understanding from those joint subgroups that what is going on and understand the development of data spaces. And there are some new which have been evolving now. It's first of all this data space design. You might want to understand that what is going on, but also understand that how to do design on the data spaces. You may have some building blocks, but then again you need to have more methodology and ways to do that. And there's something forming business value and trustworthiness of industrial AI, which are now under work. And of course I do hope that many of you get the spark now to look at that what we are doing and come join us. Then something that what we have been doing earlier with the subgroup is that we started like in 2018 to work on a white paper called Towards European Common Data Sharing Space, and that was the time when we were just wondering still that what is the concept of data spaces, and that was the paper was released in May 2019, and it was updated and released again in November 2020, and it approaches data spaces from a high-level vision on what data space can be, and so the idea is that European the data sharing will eventually happen in the European data space, where you can share data seamlessly across domains and borders and create a really European data economy. So that's the perspective, instead of looking at domains only. Anyhow, another contribution of the paper is the data sharing value wheel, which describes core pillars and principles of the envisioned data spaces, and the wheel expresses that we need to take into account all the core pillars. That's the trust is in the center of the activity. Then we need common rules when governing. We need to take into account citizens, the people, and fairness, data use. Organizations need a data culture, and well-designed technology support the advances and the high-quality data itself. So this is like a distillation of many workshops and discussions and questions that how our like colleagues see that what is the data sharing, what kind of issues there are, and then going to more towards the general vision, and then going back and forth to understand the situation status. Then we also took an outline, the time frame for next decade, and try to visualize that what kind of actions would we like to do. And in the image now you see only the sort of like a relational estimation of where the main effort would be in 10 years time. So according to this, so idea is that it's the time to do convergence find the common rules and ways of working and technically, as well as considering the regulations. And while I'm doing more and more experimentation, standardization, and how to do things, and eventually come to wide-scale deployment. Yeah, there is also quite a lot of actions that we need to do. The paper describes some of them. I will not go into that at this time. But there are surprisingly, the main bottlenecks seem to be other than technical in nature there. So when we go deeper into the challenges, there are a lot of them, and then if you make a list, it really must be then non-exhaustive, because you encounter them all the time when working on them. And here I just briefly browse through some of them to nourish the discussion and ideas. And first there are these business and organizational challenges, and first this EU values. Now when we are building new systems based on EU values, we need to ensure that there is a clear business value in that. That's one first approach. Then global competition, obvious, but we need to make our made in the EU products and services competitive. And dynamic ecosystems, okay, there's quite a lot of moving parts. How to guarantee data producers full control over data access and usage of the data. Also, legal and technical issues appear, and need to be solved. Digital transformation is happening. It means that there will be organizational disruptions ahead. That we need different kinds of transformations at that level of products, processes, platforms, people. Skills, we do not exactly know what kind of jobs there will be around the corner and what kind of changes in business processes will happen. Trust, somebody already said that. So lack of data sharing trust and motivation, and even confidence in the quality of data, and valuation standards. So seems to be quite fairly difficult to determine the value of data, how to price data and who sets the price, and so on. So there's a need for models and guidelines on that. Okay, I think that there was already colleagues in other presentations brought up nicely some of the technical challenges, but here are some more, and maybe overlapping a bit also that how designing the data sharing into existing and future data lifecycle management models, how to do that. And then digital sovereignty. The data producers should keep their rights as original data owners, so how to do that. Decentralization, I think, appeared also. There's a need to guarantee that the data producers remain in control of their data in that environment. Veracity, we will need to carry traceable information about the origins of data and what has been done to it. Security, yeah, well, secure access control is important. Privacy protection and the maturity of privacy technologies. So many things, and then you can open up quite a lot of every one of these. Then last slide is that there are also legal compliance challenges that on data protection, and the compliance is there that how we are able to use those regulations that are like brought from the EU or national regulation organization, how to bring them into use, and that's one big thing. Free flowing data, how to get data moving, and there are ownerships and other blockers. Privacy preservation, yes, in open data especially, and finally the regulatory compliance. So that general uncertainty, there's uncertainty around data policy. So that's an issue. So I think that there's quite a lot of issues, and when you start, let's say, designing the data spaces, then you have to take understand and take a look at so many levels, and so we clearly need some kind of systematic ways of understanding and how to create the data spaces so that they are fluently interoperable and actionable in the future. All right, I think that was my final slide. Thank you very much for the time here in the slot.
Thank you very much, Tuomo. So unfortunately, there's still more challenges open than we thought closed already, but I think that's good because we're here in the research and innovation ecosystem. So it's always good to have challenges, right? So we're officially almost at the end of this session, but we have a 10 minutes kind of buffer, which we're allowed from the organizer. So I would like to use this opportunity to just a round table with one final question for me to each of you. We haven't received anything from the audience in the meantime, so you'll have to deal with my questions. I would start actually from our last presenter, from Tuomo, and then go back to our first. So Tuomo, you showed this nice picture where you show a little bit the roadmap of when we can expect the data platforms, data spaces to be deployed and operational. I was wondering, do you see differences among the different sectors, or phrased differently, may there be sectors which are much more ahead in deployment and thus could serve as reference example for other sectors, and including logistics, of course, if there's others much more ahead?
Yeah, definitely. This was a generalization, abstraction of what can happen. But then again, it is clear that we need this kind of like spearheads in order to understand the needs, the requirements, and so on. So yes, that's true. So different sectors may have different speeds, but then again, this one of the last points was this regulatory compliance. So also we have that aspect to take into account in order to make these kind of scalable and actionable data spaces. So it's very complex game, I would say.
Yeah, fully understand. Okay, thank you. Very, very interesting. Santiago, you showed this very nice picture with these different stakeholders in the port coming together and sharing data. You see any ideas, obstacles, models, thoughts on how to incentivize them really deploying their data, and others then adopting this data? Because of course, having a platform is one thing, but then having it used in a kind of multi-sided fashion may be another.
Yeah, I think, you pointed out to one of the main issues in this kind of platforms. I mean, the data that each one of these organizations has is their know-how. So they are most of the times very reluctant to offer this. And if they want to offer, they have to have a clear view on the purpose of what is going to be used, and they have to have a clear view on the benefit they are going to get. So I believe researching on the business model, exploitation capabilities of this kind of data spaces. So what is the real value in each one of the value chains? So following the value chain, just checking that everyone inside is getting benefit, and there is a clear view and has a complete trust of what they are offering and where the data is going and so on. So I believe that's a key point. And yeah, I believe this deserves quite a research on business and exploitation strategies, and of course it will depend on the actor, but yeah, I believe this is one of the most challenging things in this kind of project. So just making clear what's the benefit, what's the value, and so on, and give the step for the stakeholder to share data inside the platform.
Thank you very much. So I think we agree on that. And again, this could be good to have some also reference examples from other platforms, other domains, because I think we share this common problem. Fotis, I said this before, I very much liked your take on this circular economy. I was wondering whether this means also you have to rethink the data collection, because the flow of the transported goods may reverse, and thus also maybe the data flow has to be conceptualized or reconceptualized along this new direction.
Yeah, indeed, very excellent question about that. About the data flow, we are searching about ways how we're gonna reuse data, because nowadays we source data, we see the data, and we try to make some decision out of it. Now we try to see how we're gonna correlate it, and how we're gonna relate it with data from different data points, not only coming from our assets, but from external sources in the market. So to have like a broader, let's say, concept of how we're gonna use and reuse data. In that sense, we try to accommodate the circular economy to create value out of data. And this is the circularity in a way, not source and then see the data and then throw the data away. How we're gonna handle that? We try to, not in the process of how we're gonna exploit it, but how we're gonna exploit it in a fast and efficient way. So we are talking about edge computing, like processing into the vessel, because it's different to send the data back to the office in order to see how you're gonna see and come up with a decision over there, and then transmit it back to the vessel to the decision to the action, let's say, of the decision that takes place over there through the master. So in edge computing, you process the data right on the source of the data, and then you reach a decision itself. So in a way of reusability and edge computing, this is actually how we're going to moderate the data flows in order to reach, let's say, concept of circularity in a way. But this is a researching process. Okay, fully understand. But a very interesting research problem to have. Okay, thank you very much, Fotis. Thank you.
Talking about edge computing, of course, this leads us to Angel, obviously. I was very interested to see that edge computing has now also reached the terminals and the ports. I was wondering how much dynamicity you have there. So assuming you have your edge devices in the terminal, do you have the problem of different participants, data sources, data users dynamically connecting and reconnecting from the edge devices? And how difficult may this be in the port situation?
Thank you very much for the question, Andreas. To be completely honest, I think that the worst thing for them is to try to convince or demonstrate that they don't have to restart from scratch once and again, because they have invested normally, in the case of Malta, for instance, they have recently acquired a big data system. They have made an investment, a good investment in terms of money and time, and we have to convince them that it's not the issue to start deploying a new infrastructure in order to say, okay, now it's the ones that you are going to use rather than the previous one. But in terms of data, more or less the same technical challenges, but I will say that the first approach is to convince them that it's rather than a weakness, is a better opportunity to solve higher or to improve or to deliver higher services like the ones that they are demanding with zero latency and so on.
Okay, I understand. Yeah, very good. Thank you very much, Angel.
Thank you, Andreas.
All right, Vivian, you mentioned integrating different verticals in the transport domain, these 7 sectors or modalities. I was wondering, did you also touch on the problem or the opportunities rather to connect with other domains? So energy, hydrogen, whatever you would come to mind at the moment, to really be even much broader in the logistics chain.
Yes, for sure, especially on the point where I mentioned that we are looking on the energy sector as well, and everything relates at the end on the energy efficiency and what is the welfare of the environment. Examples from machine-driven process changes, where we try to use different solutions for warehousing, for example. Electromobility, as I mentioned earlier. All these, they have, let's say, the electrification part and sustainability. It's one of the main trends as well. So beyond all, and as we have seen, especially also in the European Commission calls, the 2 main keywords is sustainability and greening. So at the very end, if you analyze even the shared mobility aspect, lately in all the calls, we try to see the challenges there and what are the possible options of presenting collaborative scenarios for a trip, inclusive more greening options from, let's say, car sharing, electric scooters, electric vehicles, and also hydrogen has been tackled, but not so much discussed within the particular subgroup yet. We've seen it in the mentionings and discussions, especially for what had to do with the ports, mainly because it was a very big call relevant to the ports. So this is how it all started. But the new calls, although they haven't been finalized here, they have specific topics of attention with the alternative, let's say, options for energy, inclusive the hydrogen and biofuels. So I'm expecting that in the new exercise and some of the topics that they will come into the table for the preparation of the BDPF, depending of the target title of the BDVF as well, we will go also into this discussion.
Okay, very good.
One very important point, though, and I think that comes first of all in all the discussions, is the micro hubs issue. So definitely we will try from the logistics sector to investigate this quite analytically and the different options there.
Okay, cool. Thank you very much, Vivi. And then we have, last but not least, Carlos, of course. I was quite interested to see this long tail picture you had about these different ports, the large ones and the small ones. I was wondering if you're going to deliver these data platforms to these many different ports. Is there sufficient commonality among all these different ports? Or what's your impression of how are the common elements so that it's realistic to have a generic platform, at least as a basis for these?
Sorry, I was muted. Andreas, thank you. Thank you for the question. You know, there are several commonalities among the different ports. It's true that the different ports handle the data with different formats. So actually, if we are able to provide them in a common format, it will be easily manageable by the platform Pixel itself. So there is a first step of analyzing the different data sources that we have in different ports, the smaller, medium, or bigger, and then being able to introduce that in the platform. The idea, for example, for one of the one that will be more common for the different ports will be the calculation of the port environmental index. And for the calculation of the port environmental index, we have identified different KPIs. So with all these different KPIs, we are able to create this composite KPI, this composite index that is the port environmental index, and with it we provide a value. So for some values, probably we will have a port that doesn't have a container terminal, but they are doing with bulk goods, or other on the other hand, only with containers. And probably we will focus in some ports that doesn't have train, and they are only working with cars, and others will work with passengers or not. So the point is that all the we can make simplification. So the idea behind Pixel is to be able to fit every kind of port. And the good thing is that linking with Santiago's explanation is that, for example, the port of Thessaloniki is a stakeholder in Pixel, but it's also a stakeholder in DataPorts. So the same data can be used for different services. For example, the data about the entrance in the port and so on can be managed and can be used for the calculation of the port environmental index, and at the same time can be used also for the use cases that we have in DataPorts. Okay. So that's the idea. So the exportation is quite good.
Okay, fully understand. Thank you very much, Carlos.
Thank you.
And with this, I'm really sorry we're at the end of this session. We could really continue discussing, but we have to close now. Let me thank you all again for these excellent insights and presentations and the very nice but even short discussion at the end. So hope to see you in the future. Thank you very much. Bye, everybody.